Hi, everyone. My name is Robin Beck. I'm an education engineer here at HashiCorp, and I'm excited to be with you for today's Learn Lab content focusing on Boundary and Vault. This session focuses on configuring HCP Boundary's credential injection feature to enable the use of SSH certificates issued from Vault. We will explore the value offered by credential injection and then walk through a step-by-step example of configuring certificate injection using HCP Boundary and a Vault dev server. During that section, I encourage you to follow along with the lab content, but you'll also be able to try the lab later if you prefer. If you're new to Boundary, consider reviewing some of the Getting Started resources that discuss why you might pick Boundary as a secure access management solution. Our cloud documentation outlines HCP Boundary, which is the managed version of Boundary you'll be trying out in today's Learn Lab. Today's lab content also applies to Boundary Enterprise, but HCP Boundary makes it simple to get started for the purposes of today's lab. Additionally, we have some great content targeting HCP Boundary in our tutorials, which you can find in our new developer portal at developer.hashicorp.com. We also have some great explainer videos that give an overview of why new access management solutions are needed and how Boundary fills that space in the Zero Trust ecosystem. Now to get into the content for today's Learn Lab, which focuses on secrets brokering using Vault. Vault is a credential management solution from HashiCorp you're all likely familiar with, but if not, don't worry. Today's implementation of Vault is simple from a configuration standpoint and demonstrates the tool's ability to act as a credential source for Boundary. Vault secures access to infrastructure resources by tightly controlling access to target credentials based on client identity. Boundary takes that value proposition a step further by securely monitoring and managing the user sessions that those credentials are used to create. In addition to providing an identity access management workflow, Boundary facilitates credential brokering as a primary feature. Boundary can store credentials itself that can be brokered to authenticated users with the right level of access. But when integrated with Vault, Boundary can facilitate access using all the credential management features that Vault is known for, like just-in-time access and ephemeral secrets. Anyone who has ever struggled to locate an SSH key sent months ago in an email or via Slack will understand that managing secrets for human use can be frustrating, difficult, and insecure. Integrating Boundary with Vault solves some of the biggest challenges in the Zero Trust ecosystem, where managing secrets can quickly become difficult in highly regulated environments or at scale. Pairing Vault with Boundary improves secrets auditing capabilities and the creation of dynamic credentials for sessions. This works by mapping credential libraries within Boundary to Vault secrets engine paths. Boundary then generates or checks out credentials from Vault to be used for a session. Starting in Boundary 0.10, users could create sessions with injected SSH private keys, as well as static usernames and passwords. Injected credentials are an improvement over traditional brokered credentials because they're never returned to user devices and are instead injected into a session on worker nodes through protocol decoding. But SSH private key and username and password injection methods still face operational and security limitations. From an operational perspective, utilizing traditional SSH keys is mostly trivial. You add your public key to a host and authorize and authenticate yourself to a host using your key pair. This workflow is usually accomplished outside of Boundary. With public key authentication, keys for each user need to be distributed to all of the correct hosts. Additionally, both private key and username password injection rely on the use of static credentials. The problem with SSH key pairs usually arises at scale. Users have to manage their public keys across all of their infrastructure, and trusted access to a machine is defined by the individual key pair. It is also not uncommon to find unknown public keys in your authorized keys file on a server that you might be administering. As you look at managing access to more hosts at scale, one of the best practices is SSH rekeying. However, most users don't do this due to the complexities of managing public keys for tens or hundreds of hosts, which results in key pairs that are long-lived and permanently trusted across your infrastructure. People leaving your organization may unintentionally retain access to your infrastructure, and even internal users that simply don't need access to a machine any longer are often in possession of these keys. In contrast to distributing public-private key pairs, SSH certificates can be used to generate unique credentials for each session and only require administrators to distribute a certificate authority, or CA's, public key to the host. SSH certificate support allows administrators to provide Boundary with a public key and have a CA that's connected to Boundary return a unique signed certificate for each session. Because a centralized CA issues certificates for hosts, access management is easier at scale. The only thing needed by hosts is the CA public key, instead of managing many unique sets of keys for each host. Certificates can be managed from a single source of truth and set to expire after a specific amount of time. Boundary's answer to the complexities of SSH is to utilize credential injection, ideally coupled with just-in-time access facilitated by issuing certificates from Vault. Boundary's integration with the Vault SSH secrets engine means Vault can be used as your certificate authority for SSH certificates. If Vault is used as the CA, certificates can be set to expire as soon as a session is terminated. HCP Boundary and Boundary Enterprise enable certificate injection, where a credential is injected directly into a user's session by a Boundary worker. Unlike credential brokering, injection ensures that a user never has access to the credential. Either the issue or sign Vault endpoints can be used to request a certificate. If using the issue endpoint, a session's key pair generation happens within Vault. Today, we'll be using the sign. Key pair is created by the Boundary controller. The public key is then sent to Vault and used to sign a certificate that gets sent back to the controller. When a user requests a connection to a target, Boundary generates a key pair. The key pair is then sent to Vault, where it's used to sign a certificate. The signed certificate is then returned to the Boundary controller. And then the public key and signed certificate are passed back to the Boundary worker, which manages the session on behalf of the user. The public key and certificate are then used to establish a session with the target. Assuming the certificate was signed by the trusted CA and has not expired, it will trust the given key. The credential injection process is very different from credential brokering, where the credentials pass back to the user itself, who then uses the credential to access the target system directly. Note that there are a couple of steps that need to be taken outside of Boundary itself, particularly setting up Vault as the SSH certificate authority and distributing the CA's public key to targets. Distribution of the public key could be accomplished via Terraform or by baking the key into an AMI or manually. Here's a deeper example of how certificates work with Boundary. First, again, note that either the issue or sign Vault endpoints can be used to request a certificate. Today, we'll be using the sign endpoint. Before anything happens, Vault needs to be set up properly. This requires setting up the SSH secrets engine and either providing a CA public-private key or telling Vault to generate one. The admin then distributes the CA public key to all of the target hosts, where the SSH service needs to be told to trust the CA with the trusted user CA's CA keys config option. First, the Boundary client requests a connection to the target. Boundary reaches out to the Vault SSH secret engine and then provides the public key for signing. Other criteria that might be needed by Vault, such as whether the user needs an interactive shell, is also passed to Vault at this time. Vault then uses Boundary's public key to generate a signed certificate and send the certificate, private key, and username are sent from the controller to the worker. The worker then makes an SSH authentication request using to the target using the certificate, private key, and username. Lastly, the target host authenticates the SSH session by using the trusted CA to verify the given certificate. If the certificate was signed by the trusted CA and is still valid, they will trust the given private key. This is all done in the SSH service implementation, such as OpenSSH. Public or private vault access is supported by HCP Boundary. Private vault clusters running on HCP can be configured to access HCP Boundary via a self-managed worker placed in a peered network via a HashiCorp virtual network. For simplicity, today we will integrate HCP Boundary with a private vault cluster running locally in development mode, with a Boundary worker also running locally to provide access to Vault. For anyone that wants to experiment with HVNs, I recommend taking a look at our HCP Virtual Network tutorial collection. Integrating private vault with HCP Boundary requires a self-managed worker to be deployed in the same network as Vault. If a Vault credential store is defined with a worker filter, the Boundary controller will know that Vault requests should be routed to workers that match that filter. This is the setup we'll be configuring today, using Vault's dev mode as an example of accessing private Vault. Now, let's take a look at the lab content. Here's a broad overview of the steps needed for an admin to set up credential injection for SSH certificates. Note that this doesn't include the out-of-band steps needed for configuring the CA public key on the SSH target. First, we'll set up Vault. Next, we'll configure a Vault credential library for certificates within Boundary. Then, we'll configure an SSH target within Boundary, specifying that credentials from our certificate library should be injected into sessions. Lastly, we will start a connection and test injecting credentials into sessions. The goal of setting up credential injection is to enable clients to easily access the SSH target using the command line or the Boundary desktop app. That way, clients can easily request connections to targets, and their session is established by Boundary using credential injection in the background. Here's a list of resources that are useful for learning more about credential brokering and injection with Boundary. The first linked resource is for a tutorial that provides step-by-step instructions for today's lab. You will want to follow this link to the tutorial to see examples of code and the lab environment to follow along with today's exercises. If you aren't able to follow along right now, you can also follow this link to try the tutorial later on. The other two tutorials shown are great resources for learning more about credential injection and integrating Vault with Boundary. If you haven't tried these tutorials, I'd recommend exploring them on our developer portal after this session. And now let's jump into the lab content for today's session. I'm going to head over to my browser. And first, I'm going to open that link that I provided for you for the tutorial that you can use to follow along with today's content. Have this open as we go along. You'll notice it requires some prerequisites to follow along, including having Docker installed on your system and the Boundary and Vault binaries. Additionally, we recommend installing the JQ utility to make it easy to copy and paste some commands through the tutorial. Additionally, you would also want the Boundary desktop app if you want an easy way to request sessions from Boundary. As you scroll through the tutorial, feel free to use the built-in copy-paste functionality for commands. You can copy a command and then directly into your terminal session. Before we get started, remember that we're going to use the HCP Boundary as our cluster deployment mechanism. So to utilize this, you'll need an HCP Boundary account. If you haven't created one, head over to HCP's Cloud Portal and set up your account. Once it's available, you'll then be able to deploy Boundary and continue the tutorial. Inside of my HCP dashboard, under the Boundary service, I'm going to click the Deploy Boundary button. And from here, I can create an instance and provide an admin username and password before I click Deploy. If you already have an existing Boundary cluster, you can use that for today's exercises. I'm going to let this cluster continue setting up in the background, and then I'm going to get started with today's lab. The very first thing I'm going to do is set up Vault. Remember, you can copy and paste these commands from the tutorial, and then I'm going to head over to my terminal session. Firstly, I'm going to need to set up a working directory for today's content. I've created a directory called Boundary in my home directory, and this is what I'd recommend that you use. You can place this directory anywhere you'd like, but ensure that you're using it for the rest of the tutorial. Afterwards, I'm going to paste that command and start Vault running in the background. This starts Vault and provides a dev root token called groot. I'm going to leave this running and then open a new terminal session. From within that same directory that we created earlier, we're now ready to begin setting up Vault and a few other pieces that we'll need. The first thing that we'll do is export the Vault address and the Vault token. Again, heading through the tutorial to grab these values. I'll export the Vault adder and Vault token, and then I should be able to communicate with Vault. The first thing that you'll want to do is enable the Vault secret engine for SSH. I'll run Vault's secrets enable, and for the path, I'll create a path called SSH-client-signer and pass SSH for the Vault secret engine. I should see that this was successfully enabled. Next, what we'll want to do is begin now deploying a self-managed worker. You'll remember me mentioning before that a self-managed worker needs to be deployed in the same network where Vault is living to provide access to our private Vault cluster. So this self-managed worker needs to be deployed where Vault is running, in this case, locally on this machine. To do this, you'll need to download the Boundary worker binary to deploy this Boundary server locally. There are a couple ways you can go about doing this. Firstly, you can navigate to the Boundary worker releases page. Visiting this page, you'll see a list of Boundary worker binaries that are available depending on the version of the control plane that you're using. You'll want to check first the version of the HCP control plane before you download your appropriate worker binary. You can do this by heading over to your HCP Boundary dashboard where you deployed the Boundary cluster before. You should see the version listed here. I'll notice that I'm running the 0.12.3 version of the control plane. And I want to download the latest version of the worker that matches that control plane version so that I can have access to the latest features available for Boundary. Heading back to the Boundary worker releases page, I can click on the 0.12.3 version in this case and download the appropriate zip folder that contains the binary for my operating system. The tutorial also provides instructions for downloading and unzipping these binaries with the command line if you prefer to do so, if you click on the appropriate tab for your operating system. Once you've downloaded that binary, move it into the working directory that you're using for this tutorial. I've already done this on my local machine, and if I check in my Boundary directory, I'll see the boundary-worker binary that I've downloaded previously. I'm going to check the version of that binary to make sure I've got the correct one by running /boundary-worker version. If all goes well, I should then see the 0.12.3 plus HCP version being returned. Now we're ready to set up this Boundary worker. To do so, I'm going to create a configuration file for my worker. I can do this by, inside of this directory, creating a new file with touch called pki-worker.hcl. PKI stands for Public Key Infrastructure, but that's just the name I'm giving this worker file that I would like to deploy. Creating this new file, I can then open it up with my code editor. Inside of this new file, I want to create a standard worker deployment that can be copied from our tutorial. So once you have this file open and available, you can head back to the tutorial and scroll down until you find the PKI worker config. You'll want to select the correct config based on your operating system, which just sets up the path that we'll configure in a moment. You can copy this configuration and then paste it into the new file that you just created. For this worker config, there are two options inside of it that we need to update. The first is the HCP Boundary cluster ID. Everything inside of the double quotes here needs to be replaced with the cluster ID from HCP. To locate this, head back over to your HCP Boundary dashboard. Within the dashboard, you'll notice a section called Cluster URL. The cluster URL can be used to access the UI. Notice everything after the HTTPS is a string of digits, up to the .boundary.hashicorp.cloud. This string is what we want to copy for our HCP Boundary cluster ID. Copy everything after HTTPS:// up to the .boundary.hashicorp.cloud. Then head back to your worker config file and paste it for the value of your cluster ID. Next, we'll want to set up a local directory where Boundary can save the configuration for our worker. This could be anywhere on your machine, but in our case, we're going to store it in the local directory where we're deploying this PKI worker config file from. On my personal machine, I can check this by heading back to my terminal and noticing where the Boundary worker binary is and running pwd to grab the path to this directory. I'm going to copy this path, that worker config file, and I'll paste this for everything up to the /worker1 value to state that I want to store the worker's local config inside this directory, and I'm making up a directory for it to live in, worker1. This is arbitrary. You could have given it any name you would like here. After you've set that up, we're all finished. But the last thing I want you to notice inside of this worker config file is the section called tags. Tags are a way for us to define what our workers should be used for or where they might be located. These are again arbitrary, but in our case, I want to tag this worker with a tag called Vault. This implies that this is the worker that will provide access to Vault later on. Additionally, you might want to deploy a worker where your targets live and tag it appropriately so that you know that this is the worker that can access your targets. We'll discuss that a little bit more later on. Save this file and then open up your terminal. Terminal session, we're now ready to begin starting this worker. From the tutorial, you can then copy the boundary worker server command that can be used to deploy this worker. /boundary-worker server, and for the -config option, we'll need to pass in the path to the pki-worker.hcl config file we just configured. You'll need to provide the absolute path here to this file, which again from pwd can be printed out. After you've provided the full path to that pki-worker.hcl file, you can run the boundary worker server command. Executing this, it should print out something called the worker auth registration request. Notice this field in the output. This is what we need to register this worker with our HCP Boundary cluster. I'm going to copy everything printed out after the worker auth registration request. After copying this value, I'm now ready to head back to the HCP Boundary UI. Back in my browser, scroll back up to the HCP Boundary dashboard. You should notice a button in the upper right that says Open Admin UI. Clicking on that, I'm taken to the Admin Console UI, where I can log into my Boundary cluster. You want to fill in the login name with the username and password you used to set up or deploy the Boundary cluster at the beginning of this exercise. After pasting in your cluster credentials, click Sign In. And if this is the first time you've accessed HCP Boundary, you'll then be asked if you would like to go through the quick setup process. I'm going to click Do This Later. And now I'm HCP Boundary UI. If you're already using a pre-existing cluster, you may have some resources here, which are just fine. But my cluster is fresh and has nothing inside of it. On the left-hand side, you should see the workers pane. If I click on this panel, you'll notice the HCP Boundary workers are printed here, and these are workers that exist inside of HCP Boundary's control plane. We're going to add our own worker that can access Vault by clicking the New button in the upper right-hand corner. Clicking on New, you'll be presented with a quick setup for your PKI worker config. The goal of this quick setup is to allow you to scaffold out your worker config file easily. We've already done this ourselves, but this template can be used in the future to locate your Boundary cluster ID, to grab a worker public address, and to create a config file. Scrolling down, notice we've already set up the config file, we've already deployed the Boundary worker binary, and now we just need to take step 3, which is confirming the worker when they connect. In the worker auth registration request field, paste the Boundary auth request that was printed inside of the output when you started the worker. After pasting that value, your worker, we should successfully see that the worker has been added. And if I click Done, under the Workers panel, I should now see this new self-managed worker. Notice the address for this worker is set to 127.0.0.1 on port 9202. And if I click on the worker's ID or name, you should see if I scroll down, worker tags. These worker tags, vault and worker, were populated from the worker config file that we took a look at a moment ago. Our self-managed worker has now been deployed and is ready to provide access to Vault. So at this point, we need to finish setting up Vault and create some policies that allow Boundary to access it properly. Inside of the tutorial, if you scroll down past the worker config, you should then come to the controller policies that we need to set up for Vault. This Vault policy needs to be defined for the Boundary controller to support the credential brokering and injection process. Notice this command is a little complex in that we are not creating separate Vault policies as files and then writing them to Vault. We're defining the policy and writing it to Vault in a single command. So when you copy this, keep that in mind. Copy this command for writing this Boundary controller policy to Vault, and then head back to your terminal session. I'm going to leave both the Vault dev server and the Boundary worker running in these terminal sessions. First, I'm going to open a new terminal session and Vault token from the first part of the tutorial. Once we do this, we'll be able to access our Vault cluster again. Exporting the Vault address and Vault token, we should now be able to write these policies to Vault. So I've copied, and now I can paste that command for writing the Boundary-controller policy. And when I run it, I should see a successful uploading of that policy into Vault. Back inside the tutorial, if I scroll down a little further, you'll see now an additional policy for setting up the endpoints that we need to manage certificates. Vault requires this policy to issue, sign, and update credentials. Notice here the path that I'm setting up is that SSH-client-signer/issue and SSH-client-signer/sign. Either of these endpoints can be used to manage certificates with Boundary. We'll be using the sign endpoint, but we'll write the issue endpoint as well in case you want to use that in the future. This is the setup you would use by picking one of these options. I'm going to copy this policy, head back to my terminal, and then paste it to Vault. After you get a success, head back to the tutorial, and there's one more section we need to grab. This last thing is a role for testing our certificates. Now, one thing you'll notice with this role is that we're setting up a default. This is going to be the user that I'm going to have for my SSH target that I'm trying to access later on. This user could be passed during the process of requesting the certificate as well. But just notice this value, the admin username, that I'll be setting up for my Docker container later on. Additionally, this is where I might define any default extensions, including the permit-pty extension, so that my user can request an interactive shell. Copy this Boundary client role, and then head back to your terminal session and paste it. You should again get a success. And the very last thing we need to do for getting set up with Vault is have Vault generate a token. Again, back in the tutorial, scrolling down, you should see create a Vault token. This Vault token will be used by Boundary later on when we use Boundary to request certificates from Vault. So this Vault token will be used to access vault from our credential store within Boundary. This again is a slightly complicated command that we're running. At its core, what we're doing is running vault token create and setting some options for this policy, including values like an orphan token, setting a period for it of 24 hours, and making sure that it's renewable. This is the command that's being run. And then we're using that JQ utility to select the .auth.client_token value from the output that's returned from Vault. And then we're storing that token value inside of an environment variable called cred_store_token. So a few steps happening in one command here, but you can run all of those steps independently if you don't have the JQ utility installed. Copy this command and paste it within your terminal session. And if it ran successfully, you should be able to echo $cred_store_token and get back the value you just created. This is available in this shell session, so you might copy it directly so that you can use it later on, which is what I'm going to do. With that all ready to go, we're then ready to set up our SSH target. Notice again, I'm located inside of that Boundary directory. If I head back to the tutorial, we now have a set of steps for setting up our SSH target. We're going to be using Docker to create this target for today's tutorial, but you could also use something like an EC2 instance in the future. If you want to bring your own target, we do have some instructions you can take a look at later under this accordion if you click Bring Your Own Target. At this point, you might want to make sure that Docker is running on your machine. After starting Docker, we'll then set up a few configuration options for Docker. In order to get this running effectively, you'll first want to create a couple of directories. Copying this command, I'm going to make a new directory called OpenSSH, and I'm going to cd into that directory. I should now be located inside of the OpenSSH directory. Next, I'm going to create two new directories inside of OpenSSH, CA and custom-cont-init.d. I'm going to copy that command and again paste it. So I should now see these directories. The purpose of these directories is that the CA directory will be used to store our public key for our certificate authority. The second directory, custom-cont-init.d, is going to be used for storing some init scripts, some setup scripts for our Docker container. Starting with the CA directory, we're going to set up our certificate authority key for signing certificates and add it to Vault. Again, the JQ utility is going to be used to parse some of this data, but you could break the command apart and run these independently if you don't have JQ. Copying this command, we're going to write this key and tell Vault to generate that public key for us. We're then going to grab the public key data from Vault, and we're going to store it inside of that CA directory, inside of a new file called ca-key.pub. If you copy and paste this command, you should then be able to check the contents of ca/ca-key.pub. It should contain the key that will be used by the target later on. Once you've set that up, we're then going to create an init script for Docker. You'll remember before that there are a couple out-of-band steps that need to be taken for your targets. We need to copy that CA public key to the Docker container or any target you want to use to access. Additionally, we need to set up the SSHD config with the trusted user CA keys option. This init script is going to do all of these steps when the Docker container boots. So this init script is simply useful to do all that when you start the container. You can do all these steps manually if you'd like to try this on your own target later on. In our case, we're going to copy this and head back to your terminal session, ensuring that you run this command from the directory. This will create a new file called 00-trust-user-ca inside of that custom-cont-init.d directory we created earlier. Running this command, you should be able to check or cat out the contents of that custom-cont-init.d 00-trust-user-ca file and see that that script has been created. With those steps in place, we should now be ready to set up our Docker container. Again, I am within the Open SSH directory on the same level as those two directories we created before. Back in the tutorial, if you scroll down, you will find the Docker run command that we'll be using to execute the creation of our Open SSH server. Looking at the Docker run command, there are a few things you should notice. First, we'll be using the Open SSH server container as our target. Second, we're giving our Docker container a name of Open SSH-server, and we're setting a username of admin. This is what we provided earlier when we set up that Vault role. Additionally, you'll notice that SSH is running on port 2222, and we're forwarding that to our local host on port 2222. This is where Boundary will eventually forward the connections it creates for you later on. When you set up to run this command, notice lines 10 and 11. These two lines are what we'll need to modify for this command to run correctly. In particular, these -v options are to mount the shared volumes that we just set up inside of the Docker container itself. We're going to mount the CA directory and that custom cont init.d directory inside of the Docker container. That will allow Docker to have access to the public key and the startup script that it needs when it boots. We'll need to provide the paths to these directories for this Docker run command to execute correctly. Copying this command and heading back to your terminal session, within the Open SSH directory, I'm going to paste this command. Remember, you'll need to adjust the /path/to/ca with the absolute path to those directories. For CA and custom cont init.d. Here's what that looks like on my machine. For the -v options, I'm providing the path to CA and the path to that custom cont init.d directory. After you've updated the command to use those shared directories, you can run this, and it should deploy the Open SSH container. This may take you a moment longer to run in case it needs to download this container image. So be a little patient while this runs if it doesn't have it available locally. Now we're ready to set up Boundary. If that's still running, you can leave it running and head back to your tutorial. And under the Set Up Boundary section, you'll notice you have a couple options for setting up Boundary. I'm going to demonstrate using the UI to set up these boundary resources, but you can also use the CLI if you prefer. In my case, I'm going to open up the Boundary Admin UI. This is where we set up our worker before. You'll notice we have some recommendations for creating the names of the resources we'd like in the tutorial, so you can copy and paste those values if you would like. Inside of my Boundary Admin UI, I'm going to click on the Orgs section. Under orgs, I should see that we have no orgs, or if you're using a pre-existing cluster, you might have some existing orgs. I'm going to create a new one for the purposes of today's lab by clicking the New button. And from here, I'll create a new org. I'm just going to call it testing-org, like the tutorial does. Clicking Save, this resource should be created. And clicking on orgs, I should see my new testing-org. Selecting it, I should see I have no projects, and I'll click the New button to add a new project. I'm going to call this SSH-project and then click Save. Within my new project, SSH-project, I should see a section called Credential Stores. Opening Credential Stores, this is first what we're going to set up to have a place where our credential libraries should exist. Credential libraries live inside of Credential Stores. So I'll create a Credential Store by clicking the +New button. Now, the first thing, Vault. We want to ensure that we're using a Vault Credential Store. That's the type we'll be utilizing. The tutorial has some suggestions for all of the fields inside of here. So if you do pop back over to the tutorial, don't be afraid to copy and paste these values here. We can call our new Vault Credential Store certificates-store, type Vault, and we'll want to paste in an address of http://127.0.0.1:8200, which is the address of the Vault dev server that we exported earlier in our CLI. Copy these values and begin filling them out for your new credential store. I'll call the name certificates-store. For the address, I'll paste that Vault dev server address. And then for the worker filter, I'm going to copy the syntax that you see in the tutorial. This is going to tell the credential store that in order to locate Vault, it should select a worker that has the Vault tag in its types, in its type tags. So this is crucial for you to select the correct worker where Vault can be found. The last thing that we'll need is to grab that Vault token that we exported earlier. If you didn't copy that down, you can head back to your terminal session. And from here, you can echo the contents of that $cred_store_token value and copy it. Once you've copied that value, head back to your admin UI and paste it in for the token value. At this point, you can scroll down and you should click Save for your credential store. You should successfully be able to save that credential store. And if you scroll up and click on the credential stores section, you should see your new credential certificates-store. Opening it up, you'll notice a tab under Credential Store called Credential Libraries. Credential libraries are what we'll use to inject these credentials in just a moment. This will also provide the Vault endpoint that should be used for accessing our certificates or requesting that Vault returns a signed certificate. So we'll click the New button to attach a new credential library to our certificate store. Again, the tutorial provides some examples inside of here. The most important thing that you can do first is select SSH certificates for the type of credential library. Opening back up the tutorial and scrolling down to create a credential library, we can copy in these values for name, type, vault path, username, etc. I'll start with certificates-library as the name. And scrolling down, I can then provide the vault path. I'd recommend copying that from the tutorial as well, ensuring that you've selected the SSH client signer's sign endpoint, and then tacking on Boundary client as that role. Paste this in for the vault path. For the admin, you'll remember this is what we used when we deployed the Docker container a moment ago. Under key type, you'll want to select ECDSA, or that's the type we're going to use. You can declare that earlier. And under key bits, we'll select 521, or type in 521. The last thing to do here is scroll down to the extensions section, where you can specify a map of extensions the certificates should be signed for. You may remember that role, we provided the permit-pty extension for the key. This ensures that we can grab an interactive shell for our session. After pasting that in for the key value, you can click Save. If you got all those values correct, we should see that we would successfully set up the credential library. And lastly, now I can click on Credential Stores, Certificates-Store, and under Credentials Library, I should see that Certificates library. With that set up, the last piece that we need to do is create a target within Boundary. Select the Targets pane off to the left. Under Targets, click the New button to create a new target, ensuring that the type is set to SSH. We'll create a new target for our open SSH Docker container. You can copy these values out of the tutorial. We'll call it open SSH-target. Scrolling down past the type of SSH, we can type in the target address. This is what was provided earlier on for the address. Essentially, this Docker container is running locally, and it's available on port 2222, which is what we set when we ran the Docker run command. For the target address, I'll type in 127.0.0.1. And for the port where SSH is running, 2222. One thing that's nice to set under maximum connections is -1 if you want to allow an unlimited number of connections per session. The workers section at the bottom is particularly important. There are two types of workers we can set here for our targets. The one that we're going to be utilizing is called the egress worker, and we need to specify an egress worker filter. Egress workers are workers that have access to the target. These are workers that exist on the same private network as the target that we're trying to access. We're in an interesting situation right now where inside of that PKI worker config file that we worked with earlier, we have two tags set on our worker. This is because in this lab environment, the worker that is on the same network as Vault is also the worker that's on the same network as our target. This is unusual. Usually, you would have a worker inside of the same network as Vault and a separate worker living in the separate network where your targets are located. For today's lab, we've kept the setup pretty simple. and these workers are the same, but we've specified different tags for those workers in order to make the setup a little bit more realistic. So this worker tag worker is the one that we'll use for the target worker filter for our egress worker. If you want to copy this worker filter out of the tutorial, scroll down to the Create an SSH Target section and copy the egress worker filter to look for the worker in tags type. I'll flip the switch on egress worker filter and then paste that filter value. HCP Boundary and Boundary Enterprise also provide a different type of worker called ingress workers. If you want to create a chain of workers to provide multiple hops when establishing a session, you can do this to provide access, deeper levels of access to network enclaves. Check out our multi-hop sessions tutorial to learn more about ingress workers. You can now save this target. If you scroll up to this target's details page, notice the section or the tab called Injected Application Credentials. This last crucial step is to select that tab and click Add Injected Application Credentials. Clicking on this, I will select the certificates library that I created earlier and click Add Injected Application Credentials. Now, our target is ready to inject these credentials when a session is requested from Boundary. To test all this out, I'm first going to go to the HCP Boundary UI from before. Remember that cluster URL section that we used to grab the cluster ID? We can now copy that cluster URL, copy its entire value, and then you can open up the Boundary desktop app. The Boundary desktop app, you'll want to paste the cluster URL and click Submit. From here, it will ask for the login credentials, and I'll provide my admin credentials I used when I After signing in, I should now see my open SSH target, and I can click Connect. And the connection URL and the connection dialog here for proxy URL, it prints the local host and a port that will be used to proxy your connection through Boundary. I'm going to copy those values, particularly the port, and head back to my terminal session. To test all this out, I'm now ready to run SSH against 127.0. and provide that port with the -P option. When I run this command, Boundary will then proxy my connection through this port, and I can click or type, yes, I'm sure I want to connect, and it should start a shell within my open SSH container. This ensures that the certificate injection process was seamless. And we're all finished. I hope that this tutorial served to demonstrate well how certificate injection works. And that I hope that you'll join us to learn more about Boundary by checking out our tutorials inside of our developer portal. Thanks for joining us today, and I look forward to exploring Boundary more with you in the future.